Well, we're in the home stretch of the course. We've got one chapter of material left to cover, and it's actually only 4 sections worth of content if you really look at it. There's some other stuff in the text that we won't be talking about. We've been dealing with probability. We're going to be talking about sort of its cousin, statistics, in this final chapter. So, statistics in a broad sense, you can look at as sort of like the science of processing data in some sense. As the PowerPoint slides suggest, it breaks down kind of into 2 broad categories. Most of what we're going to do is what you would call descriptive statistics. We're looking at ways to organize or summarize or report data. What we're going to be doing when we get toward the very end of what we do in this chapter starts leaning into that sort of second branch, what you might call inferential statistics, where you're trying to use your data to draw conclusions or make predictions, something along those lines. So for now, we're going to be talking about descriptive statistics. This particular section is actually all about grouping and displaying data, essentially. So one thing I do want to mention, because it does come up, this notion of population versus sample. So, I mean, in broad strokes, a population is effectively everybody, in a particular data set. Maybe they're not people, but, you get the idea. All of the data values for something in a given set. Generally speaking, we don't get information for the entire population unless it's something really small, unless it's, by the time it's gotten bigger than, say, like the United States Senate, getting hold of data values for every single member of a population can be a bit of a hassle. So instead, we normally work with what we call a sample of that bigger population. So one last time, you could sort of envision this as a Venn diagram, the population sort of representing a universal set, and then the sample as, like a subset inside it. So I'm not going to draw that up. We've seen that Venn diagram picture enough at this stage. I think we're all okay without it. All right, so we want to group up data sets. Generally, they're kind of big and bulky, and it's not terribly informative just to stare at a big honking list of numbers. So we want to try to find some way to break that down into an easier to digest format. So the big way we're going to do that in this section, when it comes to grouping data, we're going to use what we call a frequency distribution to see how often specific values turn up in our data set. So that's our objective for the rest of this video, and the one that comes after it as well, to be frank. So we're going to be building up frequency distributions, and then we'll see a couple of different ways you can display data once you've got it assembled into a frequency distribution. All right, so a frequency distribution is essentially a table, or I like table. Chart tends to lean a little more visual, and that's some of the other stuff we'll be talking about later. So we take a big data set and sort of collapse it down into similar values or categories of values. So I've got one example sitting in the PowerPoint slides where I gathered up partway through the year NFL win totals. I think it was from the year 2017. So feel free to chastise me. Again, I didn't gather whole season data. It was I think it was like week 9 or something like that. I will hardly confess I'm not a football person. Anyway, so you got that data gathered up. You got 32 different win totals at that point in the season. So it can be a little, chunky to process. So what we'll do instead is collate the data into a table. So we've got win counts and then frequency with which a team has that number of wins. So this particular season, we had a team with 1 win, and it goes up, I think, to 8 wins in total. So, and we can represent that. I'll do this sort of like we did. I promise it's not a truth table in case you're worried, but this way it's a little easier to line up what's going on. My apologies for the scattered widths here, but hopefully you get the idea. All right. Looking through the data set as it's presented to us, there were 3 teams with a single win at whatever point in the season I was looking. Similarly, if you count through, there were 3 teams that only had 2 wins. All right, so moving on to 3 wins, there's a lot of them sitting right there. If I counted right, and I'm pretty sure I did, I went over it multiple times, there were 10 teams sitting at 3 wins. Going to 4, I saw 7 teams. 5 wins, there were actually 5 teams. That was kind of an odd bit of symmetry. And going down through the rest, it's not too tough to count the rest of these because they don't show up all that often. There were 2 teams with 6 wins, and then 1 team each with 7 and 8 wins. All right. Now at this stage, we can actually check to make sure that we've gotten everybody, because if you're a football fan, I mean, I'm not a football fan in particular, but I still know this, that there are 32 teams in total in the league. So all of these frequencies should in fact add up to 32. 36, 16, 23, 28, 30, 31, 32. So yeah, looks like we got everybody, assuming our counts are right. So that's an example of a frequency distribution. So I like looking at tables like this, but I totally get that not everybody is as okay with it as I am. So you might also take this data and try to represent it in a more visual format. Like I said, there's 2 ways we'll talk about it. For now, we're going to focus on what a particular type of bar graph that you might have worked with in the past called a histogram to represent these particular frequencies. So I'm going to draw. I'm going to try to fit this in. 1, 2, 3, 4, 5, 6, 7, 8. It just barely fits. Okay, so I want a tick mark running along my horizontal axis for each of my win totals. So I'm trying to keep my head out of the way here. And what I want to do is draw a rectangle running up vertically from that horizontal axis corresponding to each category's frequency of occurrence. So I'm going to pull the data out of here. So, all right. So technically I should label that guy like frequency running along the side, but if you hadn't labeled it, it's not the end of the world. I skipped by 2 here. I tend to be a little flexible in terms of scaling so long as I can clearly tell what's going on. I don't need this to run 10 units high. Like I said, skipping by 2s or 3s in some instances is okay. All right, so what I'm going to do now is draw a rectangle running up, kind of centered on each of these tick marks. So I had 3 teams with 1 win. So around my 1, I have a rectangle that goes up halfway between the 2 and the 4 tick marks. Make sense? Cool. I assume you're okay with it. So same thing happens for 2 wins because it's the same frequency. So I basically just get another rectangle, same height. All right. 3 is big and bulky. It goes all the way up to the 10 mark up here. And my rectangles are kind of wobbly. They usually are because I'm kind of the shakiest gun in the West when it comes to drawing. But so we had 10 teams up at 3 wins, 7 teams at 4. So that would be halfway between 6 and the 8. All right, 5 teams was 5, so that's halfway between 4 and 6. These are generally, I'll be doing these with sketches. If you were wanting to be more precise, you probably use some kind of software package to generate it, but you get the idea. So, all right, so then we have 2 teams with 6 wins. So, tracing back over here. All right, and then we have 1 team each at 7 and 8. I'm gonna kind of cheese that a bit and draw out 1 fat rectangle and then cut it in half between 7 and 8. So here's a histogram representing these particular win data. So hopefully that makes sense. So that's one example. The trick is, for NFL win totals, it works out pretty cleanly because they don't play an awful lot of games in a given season. I mean, the catch is, though, even if like say you'd wanted to get data for the end of the year instead of like this mid-season thing that I did, that can be a bit more of a pain to look at because then you'll probably have a team with 13 or 14 wins, maybe up to 15, time or 2, even 16 wins because that's how many games they play. And then you could have a number of teams toward the other end of the spectrum that only won 1 or 2 or maybe 3 games all year long. So you've got an awful lot more values. This chart gets an awful lot chunkier. Never mind if you're dealing with another sport like the NBA or, heaven forbid, Major League Baseball, which is more near and dear to my heart personally. And I'm going to do something with Major League Baseball win totals in just a sec. But in that instance, listing every single win total is probably not terribly meaningful. So in that instance, what you probably want to do is group up the data kind of into clusters. Our textbook, I think, uses the term groups. You'll hear it called intervals, classes. There's a whole lot of different categories you could use. So I'm going to pause this while I clear off my board here, and then we'll take a look at some stuff. All right, so that's cleaned off. So I want to take a look at these baseball win totals and try to set up a frequency distribution for them in groups. Generally speaking, I mentioned in the slides, you usually would use like from 4 to 8 groups. I'm going to use 5 in this instance just to play around with it. That means you need to figure out exactly how wide each of your brackets or groups, or again, whatever you want to call them, is going to be. So general rule of thumb to figure out how wide those need to be, take the biggest data entry in your list, the smallest data entry, take their difference, and then divide by however many groups you would need here. So in this instance, the highest win total I saw was 108. I had 47 wins down at the bottom end. Dividing that by the number of groups in question would be 5, like I said. Now this gives us a decimal. If you're working with something in a decimal format like this, always round up. Got that? Always round up. So this actually is going to go, it's 12 point something. I'm rounding it up to 13 in this case. Okay. So got that taken care of. Now when I set this up, the setup here, there are times I kind of wish our text didn't do it this way, but they do, so I'm just going to roll with it. So they like listing these inequalities here, so I generally start from the bottom, and I'm going to have the same kind of setup all the way through. So, all right. So now here's how I build these suckers up. So now I'm just going to take that width and sort of sequentially add up here. So we have 60, 73, 86, 99. Then I repeat the process to get these upper bounds. Notice these are not or equal to inequalities in each side. So if the team has 60 wins, they go in here, not in the one up above. So that's kind of keeping in line with the way the textbook presents these. When you look at WebAssign homework, I've done it other ways in the past, but again, this is the way our authors do it. Okay, so now when I grab these guys into their individual brackets, here are the numbers I came up with. Again, if you need to calculate, in class, I'll often sort of have the list up and I mark through examples on the whiteboard as we have them on display. So in any case, here are the numbers as I worked them out in this case. So 2 teams in this window, 6 here, 9, 10, 3. Again, you add those up, that adds up to the 30 teams that we should have in Major League Baseball. Okay, so there's a frequency distribution. I'll draw a histogram in the next video, but you may have noticed there's this extra column right here. Sometimes instead of wanting like raw frequencies, you may be interested in a percentage or a proportion of your data that live in each particular bracket. That's what you would call a relative frequency. That's why the REL right here. To get that, I could just divide each of these totals by the corresponding total number of values, which in this instance is 30. So if I round off here, I'd get 0.067. Dividing 6 by 30 gives me 0.2. 0.3 for that one. This guy here is 1/3, so that would round off to 0.333. And down here, I have 0.1 for my relative frequencies. And again, if you wanted to express these as percentages, you could. All right, so I'm about out of time in this video, so I'm going to hit pause. We'll take a look at the histogram, and then we'll talk about another example and another way of displaying data in the next video.